shape of Al Marjan Island is based on coral. Coral in Arabic is Al Marjan. The coral shape of Al Marjan Island allows each plot in Al Marjan Island to have its own unique sea view, and that's why each plot on Al Marjan Island has an angle and sea views either toward the Arabian Gulf or toward the island or toward the city itself.
So what we're preparing now is for a grand New Year's Eve performance located on an island called Al Marjan Island, which is part of the emirate Ras Al Khaimah. Ras Al Khaimah is one of the 7 emirates within the United Arab Emirates, just adjacent to or near Dubai, which is the more famous emirate, as well as Abu Dhabi.
Al Marjan Island always work with the expert in their fields. Grucci are the expert in fireworks globally. We are really proud to work with Grucci for the 2nd time in Al Marjan Island. Today we are really proud that Grucci have made Al Marjan Island as a must-visit destination.
So the display is going to incorporate about 10.5 minutes of firework displays along a 9,800 meter spans, continual linear length that we're firing from, basically dictated by this map that you see here. This is 9,800 meters, a little under 6 miles that we're going to be displaying from simultaneously on the island. In the conclusion of the display, we have been asked to build an attempt to break the world record for the world's largest single aerial shell. We already hold the world's record for the world's largest fireworks show, which was made up of 471,000 aerial shells. In this case, the world record is the one single aerial shell. My dad and the rest of our family built a world record shell back in 1979 and achieved the world record with a 40-inch in diameter shell. That shell weighed 700 pounds. It was different than the shell that we're building because it was cylindrical in shape, and the shell that we're making, because of what we learned from my father's experiences, and also the Japanese particularly are specialists in making these large caliber shells. In fact, they're the ones that currently hold the world record that we're attempting to break. They make, and we are making, a spherical shell, a round ball shell. The spherical shell is much more ballistically pure. It's easier to lift it from the mortar. It doesn't have as much of a drag coefficient as a pellet or a cylindrical shell. But my dad made the shell back in 1979 and experienced a whole bunch of challenges. Back at that time, I was only 16 years old, so for whatever I can learn by that, and also the pictures that we have in our archives, we've applied some of those things to making this shell. So the current record is a little over 1,024 pounds, and it's a 48-inch in diameter, a 4-foot in diameter shell. And what we're making is a 2,200-pound shell that's going to go inside of a 60-inch, 5-foot in diameter mortar. The mortar alone is 24 feet deep. We've been making the products that are going inside of the shell here in our factory in New York. All of the devices, the stars that we call them, that make that dot of color, and the streaks of sparks that come out when the shell bursts. All of that has been constructed now and been shipped to Ras Al Khaimah as individual pieces. The case, which is it's a spherical shape, it's a round shaped case, that's been made here in our New York facilities. It's empty because of the size of the shell. We couldn't ship it in a container because of the hazard classification. Wouldn't allow us to put it in a container and ship it, never mind flying it there. So we had to make all the pieces, and now I'm getting ready to go over to Ras Al Khaimah, to Al Marjan Island, and build the shell with our team from New York, build and finish the shell there on location.
Al Marjan Island is a perfect location for this event, this world record attempt, with the idea that we have a willing client who wants to tell a story for the rest of the world to see, as well as a beautiful space. They're not yet developed fully on Al Marjan Island, so we had enough fallout area to be able to produce the Guinness World Record shell. With a Guinness World Record attempt of any size and a show of this magnitude, There are many challenges for us logistically, and we check them off one by one. First and foremost, is there enough fallout area and space? Secondly, how do we take all of the things we need that we created back in New York, the components within the fireworks shell, the equipment, as well as the fireworks and equipment we have here in the UAE, bring them all together in a timely fashion. If you think about the magnitude of the show and how much equipment we need and how much fireworks we need, we're moving explosives around the world, and that is never easy.
So there's a great effort to conduct a dewatering process, to pull the water away from the mortar while we bury it into the ground. The mortar's already been pressure tested to make sure that it's not going to leak, because as everybody knows, you have to keep your powder dry. You can't put a 2,200-pound fireworks shell into a mortar where it's filled with water. It will not work, I guarantee you that. So the dewatering process is very important to be able to sustain the dry environment for the shell to be loaded in. Now, back in 1979, when my father and my family attempted the first time to break the world record of the world's largest shell, the technologies weren't like they are now. We didn't have wireless capability. We didn't have certain computer systems to be able to, from a far distance, ignite the shell like we do now. So my dad was actually lowered inside of the mortar. At that time, the 40-inch shell that we made was called the Fat Man. It was actually Fat Man 2. It was a 10-foot mortar, and they lowered him down into the mortar with the black powder for the lifting charge and set the charge inside this mortar manually. My grandmother at the time, God bless her, she was alive, and she was very attentive to the details of safety within our family. And as any good Italian mother or grandmother would do, she was very upset with the vision of seeing her son go down inside the mortar with bags of black powder to set him into the bottom of the mortar. Although we did it and it was very successful, he was able to gain the record, but she swore to him he'll never attempt that again. She will not let him do it, and we never attempted it again until now. But I swore to my grandmother, she rests in peace, she's in heaven right now looking down on us. I swore to her we would engineer this system to prevent anyone from being lowered into the mortar, as my father was back in 1979. So we've devised and engineered a system to be able to put a platform into the mortar first that will contain the lift charges. There's a wireless way of igniting that lift charge and also igniting the shell as it's lifting out of the mortar. And all of that, we had to spend the time here in the studio to make sure that we stuck to our word and not have anybody lowered down inside of the mortar. As much as I might want to do that as a tribute to my dad, but Grandma trumps Dad in this case, and we have that worked out. We have also other ways that to track the shell. For example, as the shell lifts out of the mortar, we want to capture the data on what the pressure is inside of the breech, inside of the mortar itself. How fast the muzzle velocity is, how fast the shell is leaving, because that data is very important for us in the event the record is broken. And then we try to attempt another record. Sometime, maybe my son, my daughter, or my nephew Corey will try it sometime in the future. So that information is very valuable to gather, whether you succeed or you fail. Here at our studio on Long Island in Bellport, we're engineering the installation layout, we're engineering the cabling and the systems, because it's not only the world record shell that we're firing and attempting, it's a tremendous fireworks display that's wrapped around that to lead up to the world record attempt. We have 20 pyrotechnicians that will leave in a few days, and they'll stay there for 2 weeks installing the equipment, laying out more than 12 miles of cable that's going to be stretched throughout Al Marjan Island, throughout the entire area. Every single point of discharge has a cable and a computer system that goes to it. The network that spreads out throughout this entire island is to control 22 computers to be able to have all of them in perfect synchronization. So when we do a chase from here with comets and we circle the island number 4 and then come here, each one of them hands off to another computer that's firing all of that product. So the engineering, all of the CAD drawings, all of the scheduling and training of the pyrotechnicians that are going over to the island to install the project, the explanation of what the design is about. So all of that engineering is happening now here in our studios.
So we've been working out in the UAE here since 2008. We've come real close with a lot of the local companies and labor companies. We've gone the next step on this level to actually provide a training class for a lot of the locals that we use here constantly. So we're bringing them to the next level. So we have a good crew of local help that we always work with out here that are now getting training to become more than just helpers, but pyrotechnicians to work with us, not for us. And we have our big staff that we fly in from the States and the UK and anywhere else in the world. Well, now we even have people that live here in the UAE working with us. And all together, we got a big crew of 40 men and women that put together this whole project.
We're assembling the pyro plates for the Waldorf. We're going to different angles and different pans that we have to make the scenes. And we're labeling them up with the mod numbers and the Q numbers. So that's what we're doing right now. We're just setting the plates up with the stops and the holders, and we'll be adding the product later.
Because when the guys get done building these pyro plates, according to the schematics, as they come here, I check off which module's been done to the schematic. I make sure for quality control that all the stops are in correctly, all the angles are in correctly, that they're all seated correctly. There's nothing out of place. The correct number is there and the correct angles. Just as, a second chance to see it before we start loading this stuff.
This is the E-match. So you tie this in to the wire panel. This is what plugs in on this side. And right here, spark comes out of here, goes right into the firework.
We're going to switch out from the regular wire panel to the web system. So there's 25 positions in this particular pyro plate. So I'm going to take out the 25 positions from the panel and hook them up to the web. We call the Scotch lock system.
Oh, we're good, thank you though.
Where these get put on, slide them in, all the way in. And there's a waterproofing inside as well. We take a certain pair of pliers and you squeeze all the way down until that liquid comes out. Once we complete a pyro plate and everything's wired up, we bring it over here and we have a testing system to make sure we got continuity to all the pyrotechnics that are loaded into this pyro plate. So we take the module, we take our cables on module 2, and when we press the button and the test comes, you look at all his positions 1 through 32, but we only have 1 through 25 actually in the position. So we're looking for little green lights on all the first 25 positions, which we have, meaning we have continuity to all the pyrotechnics in there. So at firing time, when a real electrical charge, heavier electrical charge goes down, those pyrotechnics will be fired correctly.
I received a call to be the captain for the Waldorf Astoria, which is behind us. First time they did pyro on this building. When we set up this program, we covered the entire rooftop, which was about 9 different levels of roofs. So we had to work with the hotel to get in and out of all these access points. It's a plan as you go thing for running wire. You sort of make a plan. If it doesn't work, you go to plan B. With a building like this with multiple levels, it's so hard to get it planned before you get there. There's always going to be a little bit of a change.
So sky etching now is a large steel plate, holes drilled in it, and what we do is we stick the product in the holes and we orientate them to either a letter or a number. On this project, we did numbers, and we did a countdown from 10 to 1, and we also did 2018.
And what I'm doing is putting this in, then we put the E-match in here, and that's what Andy is doing over here.
Monkeys stay here.
Then we put it into the mortar.
That's me.
Same thing we do with our people. It explodes and shoots up and gives you a digit or a letter.
This record's really important to my dad because our family's held this record before, and his father broke that record, and his father held that record, so from my perspective, seeing how important this is to him, it's his way of honoring his father. His father passed away when he was young. It's pretty much been my dad, holding down the fort ever since. So I feel like for him, breaking this record was his way of honoring his dad and showing his dad, I got it, man. Got nothing to worry about. I got it under control down here. It's a lot of fun. Definitely feels good to be involved, especially considering most family businesses don't make it past 2 or 3 generations. So the fact that we made it to 6 is pretty awesome. And hopefully a couple more generations to come. Now, as for the future, I'm not sure what's going to happen, but I could definitely see a future where me and Corey are running the show and holding the reins. We're setting up the racks and mortars for the pixel burst shells, and it's for the countdown. So in order to make the numbers look as neat as possible, we have to level these out, make them as perfectly level as we possibly can, and keep them in as straight of a line as we can. So we got to use these bubble levels to make sure that the mortars inside of the racks are perfectly straight up. And then we have a GPS system right here that we're using to find the location of each of the mortars to make sure that they're all in the proper spots.
The role of the personnel manager is one, to select and find who will be working on each project, finding who has the talents that are needed for each project, and to get them from their home location to the event. And for this New Year's Eve, we had fireworks shows spanning from here in Ras Al Khaimah, the Maldives, and out in Las Vegas, and also in Hawaii.
All right, what I'm doing right now is I'm following the schematic and laying out the wire panels to each location. This way when the rest of the team comes, after everything is E-matched together, you can start laying everything out and then start actually putting each shell to the respective queue. So right now we have queue 1 through 32. This will be over here on the rack of the 4-inch. We have 32 on each side so they can be double hits. So once the rest of the team comes, I'm going to lay everything out for them again, and then they'll just start dropping the shells in the respective location. The guys behind me, what they're doing right now is they're actually programming the shells. So what they're actually doing is actually putting the electric match onto the fuse. This way, once the mod tells, we'll say mod 2 Q3 to fire, that mod Q3, this will fire here. It'll get electrical current to electric match, and that's what's actually going to ignite the shell.
So what we're doing right now is we're attaching lip charges, which are measured out in the little containers there, and attaching them to the pixel bursts. So this is going to the countdown. So it's got a microchip in the top as well. So whenever it reaches a certain height, it'll discharge.
We were in charge of loading the aerial shells. There's 4, 5, 6, 8, 10-inch on my site, as well as finale racks, the 3-inch. So each of those different aerial shells were at each of my sites.
My job is to keep track of all the equipment, everything that comes in, all of our electronics, our tents, our grids, our mortars. We got to know what we have and where we have it. Everything is electronic-based, computers, laptops. We use a Fire One program. We have a combination on this program of both wired and wireless. The stuff that's out on pontoons, out in the water, it's much easier to use a wireless module as opposed to trying to cable that back to land.
We're over here doing 6 pontoons that are going to go out in the water. They're being fired by a wireless system. We'll have one person on shore that has a module that talks to the wireless modules out on the 6 pontoons.
My role in this project was to construct 2 24-inch shells and one 56-inch shell. The safety aspect of manufacturing fireworks on site requires that we be isolated from the rest of the crew and limit the number of people that come in and out of the tent. And at various times there's a lot of open composition. To mitigate the possibility of a static spark, we wear grounding straps on our shoes. All of the metal objects in the room are grounded to an earth ground. Well, probably the most critical aspect of making this large shell was the construction of the machine to paste it, which is the largest part of the job, in truth. It took 3 weeks to paste it. Pasting is applying paper around the shell. Actually, constructing it wasn't all that difficult. The matter of pasting it was the hard part. We were able to apply 2 rolls, 2 6,000-foot rolls per night. Because of the weather here, we had to do the operation at night where it's a little cooler, and the tape doesn't dry out too quickly. One of the novel aspects of this construction, this build, was the pass fires, which bring the fire from the top of the shell to the bottom to the lift charge, were actually routed into the casing of the shell, which I think is probably the first time that's ever been done. The reason we routed it was to keep the fuses from getting damaged by the mortar wall as we're loading the shell. So it was recessed into a cut route. The 24s were made pretty much the same. The only difference being that they were constructed in halves, 2 hemispheres, and then put together, whereas the big shell had a hole cut in the top and the contents were loaded in.
In order to solidify, to officiate the record, is to have at least 2 special experts that have familiarity with explosives and pyrotechnics, which obviously you all have. So what we've set up here, the 2 things that we have to measure, actually we're going to measure multiple things, but the record is based on the weight, based on the weight of the shell. So the current record is at 1,024 pounds. Okay, so if you would, the circumference, the largest portion of the shell, 55 inches in diameter is only the shell. The industry measures the shell based on the mortar that it goes into. So after we finish this, we're going to go over to the mortar and measure the mortar as well. And the mortar should be 60 inches inside. So Larry, if you would, 2,397 pounds. So 1,089.545 kilograms. We're going to get the depth, 22 feet, 2 1/4 inches. And the diameter, ooh, that's good, huh? 60 inches. On the 28th, the shell will be loaded in the mortar. It'll be picked up with a massive crane and put on a flatbed trailer and driven to the position which is about 2,000 feet away from where we're making it, the position where the mortar is, and lowered in on the 28th. And then it'll sit there for 3 days until December 31st at midnight when we push the proverbial button. Feeling pretty excited right now. We're at a critical stage because we've just transported the shell from the production area in a truck along this sandy and bumpy area to this location. Now we're doing the final fusing of it and getting ready to lift it with the crane that's behind me and lower it into its mortar. So it'll lower about 24 feet down into this mortar, which is buried in the ground right now. So I'm feeling quite excited, but at the same token, it's a critical step going forward to the final push of the button. So in a promise to my grandmother that we're not going to be lowering anybody down into the mortar as we did with my dad back in 1979. You can see the shell is up on a stand, and the shell will be lowered with the lifting charge attached to it into the mortar as one movement. So Nan, I promise you we weren't going to do that, and we're not going to do it. So we're living up to our promise.
There is a plumbing company on Long Island right next to us called Blackman. I don't know if you remember. We used to drive by and they used to have this huge, I think it was a PVC pipe on their yard. And it was so big. And every time we went by that yard, he would say, "That's my dream. I'm going to make a shell big enough to fit in that pipe." And that's what we've all known him for. So it's been a lifelong dream for him to do this. And I'm just ecstatic to be a part of it and to be by his side, witnessing this event along with our children.
We're currently attaching the GPS unit, which will be tethered to the world record shell, just for safety purposes. If it lands in the ocean, we won't be able to see it at night. We'll actually have a GPS tracking stick device on it, so we can locate it, via GPS.
So it's December 31st. Had a rare opportunity this morning to get up at sunrise and take a jog and kind of kill 2 birds with 1 stone by taking a nice 9,000 meter jog along the waterfront, along the entire linear length of the areas that we're setting up on. and stopping at each location and doing an inspection. Just a final inspection for my own self-confidence. Guys did a fantastic job. Everything looks really good. Some minor tweaks here and there, but this is a rare occasion for me to be able to be out the morning of the day of the show and have the time to go out to every single location out there. So I credit the crew for giving me the opportunity to do this because they did such a great job, and I'm now excited to get to midnight. Now it's a hurry up and wait scenario.
One of the other roles that was played on the night of the performance as well as the rehearsal is as producer. So at the Grucci Show Control, we have multiple computers and firing systems so that we can mimic and see exactly what each of the systems out in the field is seeing. We're transmitting time code, which is nothing more than specific time to the millisecond that each computer will bring in and into the firing system so that everyone is in a perfect alignment. The communication that I have with each of those firing computer operators is to make sure that they are going through our protocols or systems so that everything is checked. We do test e-matches to make sure their systems are firing. We communicate to make sure that they're downloading their software properly so that when we roll for the live performance, everyone is in alignment and perfectly, safely ready for the performance.
Since I was 16 years old, 39 years ago, it's been a dream of mine to go to an attempt to bring this record back into our family. Stand by, here we go. Thank you.
It's our great pleasure to introduce Lucia from the Guinness World Record.
Hello.
Thank you, Lucia.
Hello.
Hello.
So knowing all the hard work and careful planning that has gone behind this record attempt, to see the firework shell bursting into colors in the sky, it was a truly exciting experience. So I'm now happy to confirm that the new Guinness World Records title for the largest firework shell is an impressive 1,089.545 kilograms.
Yes.
And it measures a diameter of 60 inches. Congratulations,
Thank
you are now
you.
officially amazing.
Hey!
Midnight has come and gone here in New York City and in various places across the globe, thanks to the magic of different time zones. Let's check out the big moment around the world. Watch.
And this is something you don't see every day or even every New Year's Eve, a brand new Guinness World Record for the largest aerial fireworks shell. It happened 9 hours ago at the Ras Al Khaimah fireworks by Al Marjan Island. Congratulations to New York's own fireworks by Grucci.
Dad told me that I was firing the shell. At first I felt because he told me that it was in the script. You know, there was going to be a cue in the script to launch the shell, and me and Corey were pretty much a backup system just in case that didn't go. The showtime I was told I was the cue and that I was the one that was firing it, and it's not in the script, and it was all on me. Now coming up to the shell, coming up to time, you know, 19:30 in the script, that's when I was to press the button. The only thing that was going through my head was right before showtime, my dad told me, it's better to be a second late than a second early.
Started at 10, which there was just a few seconds in between each 10, 9. That felt like an eternity, just because, you know, I'm counting a clock to Christopher, and he's getting ready to hit the button with me. And once we hit the button, now you're watching the aerial shell go up, and as it's going, you're going, oh, come on, come on, come on. 13 seconds before the aerial shell burst felt like a lifetime.
Before the shell even launched, okay, so when I pressed the first fire button, I didn't hear anything and I didn't see anything. So the reason for that is because we were so far away from the shell that it took a second for the charge to get all the way to the shell, to get down into the mortar, to light the ignition and to lift the shell. So that second was quite possibly the longest second of my life, because I pressed the button and nothing happened and my heart sank. So then once I finally saw it coming out of the mortar and I saw it lifting into the sky, at that time it didn't feel like that long, because at that point, you know, our hands off, nothing we can do. It's in the sky, all we can do is pray for the best and hope it happens. But once it got to the peak of its trajectory and it started coming back down, my stomach sank with the shell sinking. I was like, please don't come back down. I'm begging you, just do something, but don't come back down. And then once that shell finally exploded, oh, it was amazing. It's probably one of the greatest feelings of my life, hands down.
So today is the day after. Today is January 1, 2018, and I'm standing at the location where the World Record Show was launched. You can see the little scattering of a little bit of the debris around me. A nice feeling as the sunrise comes up over the mortar. All the guys are psyched. Everything was well, and we have just some recapping that we've done now. Last night was a big learning experience on top of being a big success. Some of the things were that we had to change or tweak a little bit were the lift charge, for example. We originally thought the shell was going to weigh around 2,200 pounds and be 56 inches in diameter on the inside to fit into a 60-inch mortar. The shell actually turned out to be about 2,397 pounds, so it was heavier by about 5%. So we took the lift charge, which we thought was going to be about 140 pounds, and increased that lift charge to 150 pounds. And looking at the video and watching it over and over and over last night after the display, we see the shell was rising still as it broke, which was good. You're trying to get the shell to be just about at its apex and losing energy and losing momentum when the shell explodes. And when you look at the videotape, you could see it's just about there. So that was perfect. The other thing was the size of the shell fitting into the mortar. We were looking for about 2 inches of space between the outside wall of the shell and the mortar, and we were very close to that. The stars themselves, they all performed very well. There were some that we saw as far as a lesson for the next time, if we do have a next time, that we would do maybe a little differently with the stars to make sure that we get all of them to survive the burst, the strength of the burst when they come out in canopy from the center of the burst to the ground. We got actually a higher altitude out of the shell than we were initially estimating by about 27 meters, believe it or not, only about 100 feet. When that lift charge ignites and pushes that shell out of the mortar, there's naturally a recoil force that works against the mortar itself and pushes to an extent the mortar into the ground. And we could see here by where the logo is, it pushed this 25,000-pound mortar, 60 inches in diameter, it pushed it into the ground about 6 to 8 inches that we've calculated. At show control, that's pretty much the epicenter of the energy that's then projected out with time code and the technical aspects of producing the program. So we're basically controlling the run of show from that location. And that's typically where I'm at on these types of productions. And this time was very, very special. Not only was it special, it was pressure-ridden in a different way. You have the pressures of producing the show, and you have the pressures of that first launching of product going up on the entire island. And when that happens, then you're relieved and the show continues on. That's the general feeling. And you got this energy building for the finale, but you have a concern because you want nothing but good things for the show and safety and in production and so on. This one ended with the higher pressure item, which was the world record attempt. So during the entire 8.5 minutes of the main program, my stomach was turning naturally, and I'm watching the shot clock, and I know at 19:30, precisely on the shot clock, the timing, Christopher and Corey were going to push that button, and we were doing that manually. But I'm watching the clock tick down, and I'm watching the show unfold from a beautiful perspective and watching on what my design did and whether or not it came to fruition, and I was satisfied with that, but I always had the lingering feeling that 19:30 is coming up on the shot clock. But as it was approaching, and then as we started to fire the sky etching countdown, I could feel things starting to tighten. And it was an unbelievable feeling to sense that. I was thinking about my dad, so thinking about my grandmother and the rest of our family. And there was a lot of things rolling through my mind. Once it launched, watching the countdown come, and I heard the comets fire, and I saw the comets fire on the bunting around the base, and I saw that tail come through those buntings. That was the first relief of one of the first things that could go wrong, is getting it out of the mortar. That's the first big one. When that went out, it lifted, as I remember saying, it lifted. So that was the first big, and I'm getting chills even saying it right now, is a big relief. And then as you watch it climb very elegantly, and it happened to be 13 seconds it took to climb. We calculated 15, 13 is a lucky number, and it burst at 13 seconds. But as it climbed and you saw the tail kind of release from the shell, and you saw very gently, you just saw the shell continue to go a little bit, and there was this pregnant 2-second pause of silence. And in my mind, I'm like, it's not gonna burst. And then finally, when it burst, that was just a release of energy from me and a relief. I just couldn't hold that back, and I think I may have squealed a little bit on the videotape, but it was a great feeling to see that burst. And having Debbie, my wife, by my side when that all happened was fantastic to embrace and really feel good about something that we all accomplished, the entire family and our fantastic team. One moment I'll live with myself, but I'll have that for the rest of my life. And it's a fantastic feeling to have that.
It's really our pleasure to welcome people all over the world to our emirate, to Al Marjan Island, to explore multiple opportunities available in Al Marjan Island.